Traditional software engineering assumes you perfectly understand every requirement at the start of a project. When a university develops an internship management system, the timeline is mapped out as a strict sequence. You finalize all requirements, then move to design, then coding, and finally testing. But halfway through the coding phase, the client realizes they need a new feature: automated reminders. In a rigid, sequential model, this single change disrupts the entire architecture, causing the schedule to push back and the budget to bloat. This friction occurs because predictive models treat late-stage changes as failures. Massive specification documents, written months prior, become obsolete instantly, forcing developers to rework components that were supposedly completed. In modern development, business needs, competitor technologies, and user expectations are in constant flux. A fixed plan cannot survive a volatile market. The Agile Manifesto addresses this by reprioritizing how we build. It values direct customer collaboration and delivering working software over rigid upfront planning and static documentation. Agile replaces the drive for upfront predictability with an empirical process control model, one that treats changing requirements as an engineering asset rather than a project defect. To physically execute this, teams use two specific mechanics. The first is incremental delivery. This is the process of building and releasing the system architecture in small, discrete, functional parts, adding new features to the live environment one by one. The second is iterative development. Here, cycles are repeated to improve an existing feature based on real-world usage. You don't just build the login once. You refine it across several cycles to enhance security and user experience. Modern Agile teams run both of these mechanisms simultaneously. They add new pieces to the system while refining the ones they've already delivered, compounding value with every release. In our internship system, Increment 1 might deliver only a basic student application portal. Increment 2 would then add company profiles, while simultaneously iterating on the application portal to streamline the workflow. This dual-access approach limits project risk. If development stops halfway through, the client isn't left with an unfinished codebase. They possess a fully functional, usable subset of the final system. To fuel this continuous delivery, massive system requests are broken down into manageable work items called user stories. This ensures that every task being performed has a clear, defined business value. Every user story follows a specific syntax. As a specific type of user, I want a specific goal or function, so that I gain a specific benefit. As a student, I want to submit feedback anonymously, so that I can provide honest evaluations without fear of grading bias. But a single sentence doesn't provide enough detail for an engineer. To be considered done, each story must also satisfy acceptance criteria, the strict binary conditions that prove the requirement was met. For our anonymous feedback story, criteria would specify that the system must encrypt student IDs and the interface must show a clear confirmation message after a successful upload. This framing forces developers to focus entirely on the end user's objective. They are solving a specific problem rather than just checking off technical tasks. This diagram outlines the Scrum framework, the most common mechanical engine used to operationalize Agile. It manages complex product development through fixed time boxes and specific mandated roles. The process depends on three roles: the product owner, who maximizes product value, the cross-functional developers, who build the increment, and the Scrum Master, who facilitates the process and removes blockers. It begins with the product backlog. This is a prioritized list of every feature, bug fix, and technical improvement needed for the product. During sprint planning, the team selects high-priority items and commits to finishing them within a fixed cycle, or sprint, usually lasting 1 to 4 weeks. These items form the sprint backlog. Every 24 hours, the team meets for the daily Scrum. This is a tactical alignment meeting where developers inspect their progress toward the sprint goal and identify any issues that are slowing them down. At the end of the sprint, the team conducts a review to demonstrate the finished work to stakeholders. This is followed by a retrospective, where the team reflects on their internal processes to find ways to improve the next sprint. Scrum replaces vague promises with a repeatable mechanical engine. It forces transparency, demands frequent delivery, and builds continuous improvement directly into the development schedule. While Scrum manages project flow, it doesn't specify engineering standards. For that, teams look to frameworks that dictate how code is actually written and delivered. Extreme Programming, or XP, focuses on rigorous engineering practices. This workflow emphasizes feedback loops to maintain high code quality during rapid iteration cycles. XP practices include test-driven development, where engineers write tests before writing the actual code, and pair programming, where two developers work together to catch logic errors in real time. Alternatively, this Kanban board represents a continuous flow model. Unlike Scrum, Kanban discards fixed sprints in favor of managing real-time throughput. A central rule in Kanban is the work-in-progress limit. By capping how many tasks can sit in the in-progress column, the team prevents burnout and makes workflow bottlenecks immediately visible. Mature teams rarely use one method in isolation. They build a hybrid ecosystem, utilizing Scrum for management, XP for engineering quality, and Kanban for continuous maintenance and bug fixes. A single Scrum team works well for localized projects, but large-scale enterprise environments require dozens of teams to work on the same product simultaneously. Scaling frameworks like SAFe and Nexus provide the structure to coordinate these efforts, ensuring that mobile app teams and back-end integration teams remain synchronized across a massive digital platform. However, Agile has clear limitations. It depends heavily on constant customer availability. If a product owner or client cannot provide frequent feedback, the team risks building a product that doesn't meet the actual business need. There is also the risk of scope creep. Because Agile accepts change, budgets and timelines can easily spiral if a product owner fails to ruthlessly prioritize the most valuable work. In highly regulated industries like aerospace or healthcare, the heavy documentation and strict compliance requirements may still favor the predictability of traditional waterfall models. In the volatile landscape of modern software engineering, the ability to rapidly adapt to a changing reality is a far greater technical asset than the ability to perfectly execute an obsolete plan.